Hi, myself Deepak Yadav, and today I will walk through my implementation of ProtexAI's MLOps pipeline for computer vision dataset generation. Mainly, this solution focuses on the reproducibility, scalability, and observability while maintaining the cost efficiency. So, we will go through it step by step. So, uh, I have to explain the pipeline and how it is containerized. So the first task was to containerize the pipeline and then to provide the input path, output directory on which the images will be uh, saved, and detection model config, and also to provide the instruction on a script to run the container. So what I have done is we will go through here. So this is my overall project, and here uh, this is the most important pipeline. The pipeline is having one method which is process video, the input path on which the video is there, and the output directory in which the images will be collected, and this is the configuration path. How this will be called is from here. So these are the arguments which need to be provided while running this pipeline. So this is the input video, that is the first argument, and the second argument is the output directory, and the third one is a model configuration. So default model config uh, file, this is the one I have used it over here. So that's how. So over here I have uh, given the name of the model, which is a YOLO v8n.pt, and then also the threshold in the deduplication that I will explain later. So I will go back to my pipeline. So that's how it will be started. One of the limitation in my current setup is on this system I cannot run anything. This is just for the video recording, and the code on the system which I have written everything, it doesn't that doesn't allow me to record the video and upload because that's the official one. And this is my personal laptop on which not many things are installed, and it is just for the recording purpose only. So whatever I am showing you, it's a static project kind of thing. I can't show the exact running project. So that is one of the limitations. So this is a code I have written. So here in the processing process video method, so what it is doing, it is here this is just loading the configuration, then the model is getting detected. So this is for later on for the YOLO, when we need that model, that will be used. So this records the start time, uh, so as to calculate how much time it took to process the image. uh, that all those things, timings and everything, will be saved into the matrix. This matrix will be used in the Prometheus, which I'll be using in this project. So here this is to initialize that matrix, and then next step is to dedupe. So it's like to duplicate, to remove the duplicate frames, because we are looking for only unique frames. So this particular line is for that. And then the next one is here it's converting the frame for hashing. Mainly if the two frames are same, then their hashing code will be same. So that's how we will detect if the two frames are same or unique, and if they are different, then how much different they are. So for that we will be passing the threshold. Okay, so here we are checking if it's duplicate. If the uh, current hash and the existing hash are same, then that means it's duplicate. And if it's different and it is less than the threshold, then as well it's same frame. And if it is more than the threshold, then these are the different uh, fr frames. So somewhere over, yeah, over here I have given the threshold as 2 because the 2 means the minor variation is allowed, and 0 means only identical frames, and the 5 means aggressive deduplication. So this is the kind of you know provision we have given to check the deduplication. Now I'm going further. So that's how I'm uh, processing the frames. Actually, these are required in the later in the fourth part of the task. So I will explain. I will come back to this. So right now we'll go back to the task. So over there I have shown how we are passing the path to the input video and the output directory, and then the detection of the model config, and then so the next was the task was to implement the CI/CD style script and the set up the environment, run the pipeline end to end, validate the outputs are correctly generated. Okay, so I can't show the actual running pipeline because all the those tools and softwares are not available on this system, but on different system on which I am not allowed to record. So these unit tests and everything I will show. So we have a separate directory for the test. So this test Python file is having all the corresponding test cases of all the methods which were there in the pipeline.py. So all the test cases are written over here. So we'll go through them one by one. So this is the integration test of a full pipeline. Okay, so it is checking if the output directory is there and if their images are generated or not. Okay, and then next is checking the image quality and the consistency, and then we are checking the Coco annotation integrity. So these are the tests, and then we are also checking the one of the another major functionality of the deduplication, and then we are detecting the parsing. We are checking the parsing is taking is going good or not, and then the other metrics which we are recording for the Proximus server. So we are checking that functionality as well, and then we are checking the error handling, and this is again we are checking the metrics of the Prometheus server. Then we are also checking the logic of the report generation, whether the report generation is working perfectly or not, and then the configurations. And to also to check the output to validate the annotations, annotations and JSON and everything. So this is the file which is handling all that uh, annotations and the JSON and checking all that stuff over here. So okay, so the metrics which we are recording in the Prometheus server is that metrics is all about this number of images and the detection and the drop ratio. So this is the metrics. So it is checking the frames process total, detections and the processing second, how much time it took, and the frame drops total. Then going back to this one. Okay, in this utility file, mainly this helps in generating the report in a proper format. So for that, the format is completely defined over here. So that's how it will generate the reports. Okay. In the optional enhancement part, I have taken up this one, the frame deduplication using perceptual hashing, and then the normal input validation checks I have done, and then I have also used YOLO V8 because it's very lightweight and the very high accuracy. So so those YOLO functions are defined in this YOLO utility file to detect the objects and to load the detection model. So I'm giving its name and the version as well. And then, so for overall uh, containerization, I'm using Docker. So this is my Docker file. This is my make file, and this is my Docker file where I have defined the image. Okay, and then in the requirement.txt, I have mentioned all the requirements, all the dependencies and their versions. And then in the make file as well, I have defined the name of the image. So it's like Docker plus make file plus GitHub action. Actually, these are scalable for multiple client side, and we can easily move it to the Kubernetes for scale up. And what else is remaining? I think I've gone through all these files. Okay, now a quick summary of like why I have used, what tools I have used. So mainly I've used Prometheus because it's a like open source kind of thing. So I've not used CloudWatch. It's Prometheus is very much lightweight, and I'm familiar with this tool. And in case of YOLO, I've used YOLO V8 because it's very high accuracy. So I think it's 83.7 MAP, and then 50 accuracy. That's what I read. So I used this one instead of YOLO 5. Earlier I used YOLO 3 as well. And then it also like its inference is quite good for GPU. So these are the reasons. And yeah, what else? Let me have a look. I think I've completed quick explanation of my overall assignment. Uh, in case you need any further clarification, I'll provide the same. Thank you.